So welcome back to this segment of discussion where we will move on to learn about how to plot data frames as a time series. So when we store data in data frame meant as time series, that means, for example, row 1 will captures data for today, row 2 captures data for tomorrow, and so it moves on with time as the row progresses. So this data frame and it occurs in many situations. Then what we do is we can simply just extract. So easily draw a line. Okay, so this is to show the trend. And we can just say label C, so it gives a legend to show the legend equals to true or false if you don't want. And then we can fix the dates because remember, for time series, it's all about time. If we don't see the time in the x-axis, then it's not really time series, but this is still considered okay because time series can also be shown as discrete times. So time number 1, time number 2, time number 3. But more importantly, for uh, consume consumers to read charts or for consumption by general public, who are sort of looking at uh, the sort of betterment or worsening of certain measured quantities like a stock price or COVID-19 cases or whatnot, then we should certainly attach dates. Yeah, because the 0, 1, 2, 3 timing is more for academic studies, mathematicians, and so on, right? So we fix the dates. We can fix the dates in index to really show the time. So the new thing here that we want to pick up on is how do we kind of like copy a set of times to the index instead of letting it run naturally as 0, 1, 2, 3, and then maybe having to tweak it somehow. No need. We can actually do a pd dot date underscore range. So it's very simple. The date underscore range is very versatile. It's able to understand all kinds of date um, convention. So I put a dash here and the year first, and date underscore range is able to understand this. So it says start on this date, April the 8th, as you can see here, and keep on, so keep on increasing one day at a time. So date range automatically knows, for example, let me just see, 1, 2, 3, 4. April is a small month, so it will end. The last day is 30th, and if you plus one, it should be 1st May. But for May, 30th is not the last day, so if you plus one, it should be 31st, and if you plus one again, it's not 32, but 1st of June. So it will know uh, how to adjust the months, right? So this is actually tricky, but you can do it, right? I mean, it's not so impossible, but you don't want to because it's just hairy details that you wish someone could have done it, or things can be done automatically, and your wish has come true. We just need to say how many rows there are because each row is one day, for example, right? Then all we need to do is date range, start date, number of days, right? And then plot. So immediately the date will be shown. Notice that the date being shown by df.plot.line does not have the dash. So it's being formatted yet again for best display. So in this case, the best display as determined by the plot.line is April in the second line, 2021 the year in the third line. Okay, we can also easily calculate moving average exponential smoothing by overlaying of the plot. So if some of you have been doing stock trading or forecasting, for weather forecasting, for stock forecasting, for various inventory demand forecasting, logistics, supply chain, etc., you will have earlier experience with the need to calculate moving average and exponential smoothing on top of the original data line because you're trying to forecast into the future, right? So now that we have time series, can we do it? Answer is very simple. So let's begin with adding a moving average of forecast of all the previous dates. What you do is just do a df.c if we are trying to do a moving average on column C dot rolling. Rolling means keep moving down the rows and do what? So it's a bit like group by, when we talk about df dot group by, it produces a semi-complete object waiting for the function to be given. You want me to keep rolling down the rows doing what? All right. So I've prepared everything and tell me what's your operation. Or we want to do an averaging. So moving average is to average over, for example, the past two time periods. That's window size of 2. So all we need to do is I'm going to roll over the rows, ROWS, with a window size of 2. Then yes, then do what? Oh, then perform averaging, which is moving average. So average these two, average the next two, average the next two, and keep doing it. Except the first row for this MA underscore C, for this new column, will be undefined, will be nan, right? Because it's not able to be averaged with anything before it. It's the first row. So we expect the first data item for the first row for MA underscore C to be blank. Yeah. So then we do that, moving average 2. What if I want to average over 3 time periods? Then change 2 to 3, finish, right? The window size is so simply changed. Next, we do exponential smoothing. As we know, we need two things to start exponential smoothing. The alpha, where it is a number between 0 to 1. The smaller it is, the data should be not changing too much. The closer to 1 it is, the data would be expected to fluctuate a lot. And then the other number that we must know is, where do you start? At which point of the time series do you start? So as a matter of simplifying everything, we always start at the first data. Okay, we always start at the first data. So what we do is we simply run df.c, I want that series, dot EWM simply means exponentially weighted moving average, right? So EWM alpha, we give a number of 0.7 because the original data at this scale appears to be fluctuating. Adjust equals to false, right? And dot mean, which is basically moving average. Okay, because we're doing averaging, so dot mean. So when you do this, a new series is produced based on exponential smoothing with 0.7 alpha, and that is being stored in the ES underscore C, exponentially smoothed C. Then we try to plot three things. Plot line, label C, plot line, label MA, plot line, label ES. Notice we have the legend true one to be shown. And the last one has a grid line to activate the horizontal grid. Okay. Now, next thing to notice is that how come they are all plotted overlaying on top of each other, which is what we want, but how did it know? Because we didn't have a plot dot figure, remember? Go figure, right? So we didn't initiate a new figure, and so all the plots are being done to the same figure. So that's why we have it. Yeah. All right. So that's for time series. Very useful and can just be done simply like this. Two things to pay attention to: change the DF index to time based or else date based. So you can have date range here. All right. There's also a to date time method that pandas applies. You can convert a string of dates or times to date time format, and so that's making life a lot easier to perform forecasting, moving average forecasting, exponential smoothing forecasting. So it's just one line and then seeing it.